Question for you. How do we use sampling to create a survey that most truly represents the entire population? So we want to know something about a population. How do we do that without asking every single person? So the more random the sampling, the better the representation. This removes bias. And the bigger the sample size, the better the representation. So if we have a larger sample size, this is going to work out better. So there's a way to measure the accuracy of a sample. We have two very basic formulas below, and we are going to do this just based on some skimming the top kind of statistics. We're missing some other deeper mathematical components, but we're just going to go with it with this. Standard error is this, margin of error is this. We're going to be dealing with margin of error a little bit more. And before we go any further, let's label a few things. First of all, this is what we call the normal curve. And this is where the data is evenly distributed. So we ask a bunch of people, hey, how tall are you? And they give us an honest answer. And we graph the results. And this should be the mean. So this is going to be the average, also known as the mean. And if you want to get a little bit deeper in the statistics, you could say that this is X with a little bar over the top of it. That's what the symbol is, X bar. And then a standard deviation is how far you are from average. Okay, so let's just suppose that the average height is, we're going to go with men being 6 feet tall, okay? A 6 foot tall guy would be, 72 inches tall. It took me way too long to do that in my head. So we have 72 inches right here. And let's suppose the standard deviation would be 3 inches. I'm making the data up, right? You can do that when you're a math teacher. So let's suppose the standard deviation would be 3 inches. So we could have 72 inches tall, or we could have 3 inches less, so 69 inches tall, or we could have 3 inches more at 6'3", which is 75 inches tall. So we could do this, and that would be one standard deviation, and then we can go further, and then we can go further. And the further you are from the mean, the rarer it is. So someone that is 8 feet tall, which doesn't exist, but if someone was 8 feet tall, they'd be way under, way out here, okay? So here we go. This is within one standard deviation, just like I said. So with the data that we just made up, 72 inches tall is the mean for men, and a 3-inch standard deviation means that we're going to have a bunch of guys that just fall in this category right here, and this category is the category of, well, one standard deviation away, and 68% of the population falls within one standard deviation. So this is within one standard deviation right here. This is within one standard deviation. Bumping the camera. Better. There we go. No, it's not. 68% of the population is between, data we made up, 69 inches high and 75 inches high, tall for men. Now, we can go 2 standard deviations out, and we could say that this, for example, would be 72 inches. This is the mean. And then from 72 inches, we could go 3 below and then 3 more below. So we could go down to 66 inches tall, and we could go up 3 more and 3 more. So we could go up to 78. So there's another percent here that is missing. I haven't put it on the paper, but it is 95%. 95% of the population falls between this and this standard deviation. And then again, the further you go, the rarer it is. Okay, so what we're going to do actually is back up to this formula and talk about the margin of error. Now that you've heard standard deviation and you kind of have an understanding of what it means, we're not going to use it in the context it was just presented. We're actually going to use it in order to talk about how good a sample is, how good a survey is. This random sampling we took, are we confident that we have a good representation of the population that we're wanting to study? And this is how we're going to do it. Okay, a school randomly selected 75 out of 200 seniors to take a sample college entrance exam. That's lucky 75 folks. Let's just write down what we know. I know that the population is 200, and there's 200 seniors, so you could just say it's 200 seniors. We selected 75. So the sample size, which is, we're defining a variable now, n, is 75. So if you want to come up here and write some things down, you could. We're going to say that n is the sample size. And you can write that on both formulas. I'm going to write it on just the bottom one. We're not going to be using the top one at all, but it's fun. And then, there we go. That's going to be something here in just a second. The average GPA of the seniors was 2.95. Okay, so the average, you can call it average, you can call it mean, you can call it X bar, is 2.95. And the standard deviation, that's S, is 0.4. Okay, so that's good to know. This is standard deviation. What was the margin of error? So let's go ahead and figure out the margin of error based on what we see right here. So the margin of error is this formula. So margin of error is 2 times the standard deviation, 0.4, all divided by the square root of the sample size. And when I type all that in my calculator, I'll go ahead and save you the trouble. It's 0.092, and that gives me my margin of error. And we've answered the first question for this one. Okay, what is the 95% confidence interval? Whoa, what you talking about? 95% confidence interval. I don't see the numbers 95% on there. And I briefly mentioned that 95% of the population falls within 2 standard deviations of the mean. That has nothing to do with what we're talking about. Okay, that's a different issue altogether. That's a different 95, which is why I have not put it on the paper. So, margin of error. I'm going to work this out and then write a sentence that explains it, and then I think hopefully after that everything will click. So here's the formula, and I'm going to write out the formula in red. The confidence interval, 95% confidence interval, and the number 95 is going to come in handy in a minute. It does not come up in your computations. But it's going to be the mean minus, not plus, minus, we'll turn that to a minus, the margin of error, and then the mean plus the margin of error. So here's our interval, and it's an interval notation. It looks kind of like a coordinate, but it's not. So in this case, the mean is 2.95. Minus the margin of error. And then we're going to have the mean plus the margin of error. And we'll do a little bit of computations, just 2 separate numbers, and I'll save you the trouble of typing this in the calculator or doing it by hand. 2.858, comma, 3.042, and in addition to writing the formula in red, I'm going to write down a sentence in red that will explain this, and this should make sense. So what does the number 95 have to do with this? I am 95% certain that the average GPA of the population. Okay, let's pause right here. I'm referring to the population, which is 200 seniors. The average I got was this, but these were just the 75 folks that took the test. So I'm going to talk about my certainty about extrapolating this data to the entire population. I'm 95% certain that the average GPA of the population is in this interval. That's what the confidence interval means, a 95% confidence interval. And this is the formula, the mean minus margin of error and then mean plus margin of error. And this is the sentence that kind of brings it all together. So let's kind of talk about the next 2 problems and what we can do to change this in a practical sense, and then we'll do a few more practice problems. So how could you make the margin of error smaller? And just to solidify this idea, margin of error, the more you write it, the more you'll remember it. It's 2 times the standard deviation over the square root of n. If I want to make this smaller, I could reduce the size of the numerator, which means I have made the standard deviation smaller but I'm not allowed to do that. So what I could do to make this fraction, and hang with me now, if I want to make a fraction smaller, I need to increase the denominator. So I can take a larger sample size and if I want to make the margin of error larger, now I don't know why I would want to do that. I would prefer to have a smaller margin of error so I would be more confident with my data. But if I want to make the margin of error larger, then I could take a smaller sample size. Okay, let's move on. A study by a local school board was trying to determine the mean ACT scores of the graduating seniors. And if it helps, you can write down everything you know, and I'm going to. So the population is seniors. How many? I don't know. And it's okay that I don't know, because here I knew it was 200, but I didn't need to know that it was 200. The number 200 never popped up here. Let's see. The study found that the mean ACT score was 20. Okay, so the average was 20 with a margin of error. Well, now we have a different piece of information of 3. Write a confidence interval for the true mean ACT score of the graduating senior. So here's what happened. So there's this local school board, and they want to know the mean ACT scores of the graduating seniors. So they just took a handful, and we don't even know we don't know how many seniors they did as a sample size. We don't know actually, and we don't know the standard of deviation either. And I'm okay with that, because I would need the standard deviation and the sample size in order to determine the MOE, margin of error. I already know that. So done, like mission accomplished. I have what I need. And all they're asking is write a confidence interval. The implication is that it is a 95% confidence interval. That number's not in there, but the idea is there. Write a confidence interval for the true mean ACT score of the graduating seniors. So I'm going to waste a little bit of red ink, and I'm going to write it again. The mean minus the margin of error, and then the mean plus the margin of error. And that's going to give me my confidence interval. So let's just do this. This is going to be super fast. The mean is 20, and my margin of error is 3. The mean is 20, and my margin of error is 3. So we're at 17 to 23. So I am 95% confident. I'm going to write the sentence again so we can understand this idea. I am 95% certain or confident, use either one, I'll use confident this time, that the average, or mean, ACT score of the seniors, all seniors, is within this interval. Okay, let's do a couple more problems. Fun times. All right, a study was commissioned to find the mean weight of residents in a certain town. I don't want to be the guy that knocks on people's doors and asks people how much they weigh, but whatever. A study examined a random sample of 120 residents. Now, was it biased? I don't know. Did they go to one place rather than another? Did they go to younger people rather than senior citizens? I don't know. We don't know the veracity. That's a word. It means truthfulness. That word may not fit here. We don't know how reliable, I should say, this survey was, but we're going to go with it. Random sample of 120 residents. Ooh, that's 120 people. And, oh, here we go. Let's go ahead and list it. So the actual population, in case you wanted to know, just for reference, is something I don't know, but I am dealing with people in a town, like every resident in a town, the residents of a town. Okay, found the mean weight, okay, mean 160 pounds, with a standard deviation of 30 pounds, and use the normal distribution empirical rule. Sometimes it's worded like that. That's exactly what we're doing. I've not used the empirical rule phrasing yet, but it's exactly what we're doing. to estimate a 95% confidence interval for the mean, rounding all values to the nearest tenth. They told us where to do this. So before I ever do that, I need to find the margin of error. You're probably wondering what that first formula was for, the standard error. Something we don't use in here, but I'd like to think that you notice that the margin of error is double the standard of error. Just saying. Okay. I'm putting it there as a frame of reference as you go deeper into statistics in your life. 2s over the square root of n, writing the formula this time, just for fun. There, that was a lot of fun. 2 times 30 over the square root of 120. And I will save you the trouble. I've already typed it, I've already rounded it, and I got 5.5. I'm not going to write the formula again this time, but what I am going to do is save the formula and confidence interval, 95% confidence interval. Again, the number 95 does not pop up in our computation, it pops up in our explanation. So, confidence interval is going to be on the lower end. It's going to be our mean minus our margin of error, and then our mean plus our margin of error. And we'll just figure out what that is. So 154.5 and 165.5. And just because it's good to make sure we understand, I am 95% sure, use a different word this time, that the mean weight, average weight, mean weight, W-E-I-G-H-T, of the residents is in, it's a struggle, is in this interval. Okay, and now things get a little bit different. A survey was given to a random sample of voters in North Carolina's 5th Congressional District to ask about their preference for a candidate for the House of Representatives. The survey reported a confidence interval that between 34% and 42% of the population preferred candidate A. We're going to go with the assumption that it is a 95% confidence interval. That's really essentially what this lesson is about. The number 95 is going to happen implicitly throughout this lesson, even though we're on the last problem. What is the margin of error on the survey? So let's actually start at the end this time. So they said that we are 34 to 42% certain that the population prefers candidate A. So they walk around, they're like, hey, are you going to vote for A candidate or B candidate? And they're like, neither one. They're both dirtbags and yeah, whatever. But they had to pick 34 to 42. 34% to 42% confident that they're going to prefer candidate A. So what's the margin of error on the survey? So here's what's really going on. I have, and I'm going to visualize it a little bit differently here. I have a number line that goes from 34% to 42%. Don't let the fact that it's percent throw you off. Okay, we could have done the same thing with this problem and been like, oh, 154.5 to 165.5 pounds. We'd follow the same process. So what is the margin of error? Okay, the margin of error is your wiggle room. Like how much from the mean are you deviating? Well, first of all, I don't know the mean, but I'm about to find it. That should have been exactly in the middle, but I'm a little bit off. Here. Dropped my whiteout. Now we'll never get it back. See? It's just one tragedy after another. Here we go. Fixed. You never know it was messed up. There we go. That's a little more halfway. Okay, halfway in between 34 and 42 is, well, average them together, you're going to end up with 38, which kind of makes sense. They are 8 units apart. Half of 8 is going to give me 4, so I'll go 4 units up and 4 units down. I should get to the same number. Now, actually, I just sort of answered the question. What is the margin of error on this survey? Well, good to know this. This is the mean, but the distance from the mean takes me down or takes me up. So this distance right here is 4, and this distance right here is 4 percentage points, if you want to look at it within context. And so this is also 4. So the margin of error is 4.